Okay, for folks who are joining this live stream, this is one of our internal meetings about incremental language development for Wolfram Language. So we have a variety of topics for today. Let's start off talking about around. Oh, these are, okay, so this is graphic design for, okay, what does this one mean?
So we have Jeremy with us to comment on this. So yes, so the last time we were discussing both the design of the standard error, this expressing the full error, and then the error in parentheses, meaning only error on the last digits.
So this one here means plus minus 23 on the whole number.
Yes, I think this should be like 0.23. I think that's missing a 0.23, but yeah.
Well, could it ever be? Yeah, that's right. In this configuration, it could never be. It has to be something which is to the right of the decimal point.
Exactly. Yeah. Without parentheses, it would be. But yes.
Right. But this could be 114.1234 plus minus 0.001210 or something, right? But it can never be more than two. But those two digits might have to be right shifted by giving a 0.001. Get what I'm saying?
Yes.
Can I type something different here, or is this not? Is this just a fake?
Perhaps if you change the previous cell.
Yeah, the previous I just used percent to increase the font size. So
okay.
That's style 23.
By the way, you're sounding really weird, Jeremy.
Yeah, I think if you change 23 to 0.
But that's never correct either. That couldn't be correct either, right? It would have to be this, because it's not going to. It's got to go down to the last digits of the first number, right?
Yes, indeed.
Okay, so that's a real case.
Yeah.
Okay, so what I'm saying is, if this was 0.33318, this would end up being 0.00023.
Exactly.
Right? Which I think is fine. Is Michael on with us or not?
No, unfortunately, he had an external meeting to attend.
Okay.
So you like the idea of having the error smaller than the main number?
I think this is nice. Yeah, I think this is nice.
We roughly agreed on this last time. This is just the implementation.
Okay. Well, I'm happy with that.
Yeah.
Mm-hmm.
Okay, now what's this case here?
Yes, so this case would be, again, this case, the 2.3 should be a 2.30, for example, in which it's...
Let's get it right. Let's get it right. What are you saying it should be here?
Change the 23 to a 2.30, for example.
This one here, 230.
Yeah, exactly. So this is the case in which we are denoting the error on the last digits, because there could be many more digits before the parentheses.
Right. As opposed to this, which is the absolute error on the number.
Exactly.
And how do we distinguish when we're using this case versus this case?
Well, that's a separate question. The idea would be either to have an around form or to have something inside the round, but I would prefer an around form.
So would I. But are we going to auto switch? Because I mean, what is, I don't know, the anomalous magnetic moment of the electron? I don't know why I'm, well, you know why I'm picking that.
Yeah, just a standard case could be the Avogadro's number, which is very large.
Well, okay, so wait a minute. Let's take, what the heck? How do I get something reasonable with this? Okay. But that has more digits, right?
Yes, indeed. So this is a number that could have an error in the last few digits. So yeah, I see your point that we could have by default a typesetting that switches to the parenthesis notation for.
I think we should. Yeah, I think we should. I think that honestly, by the time this is probably almost the extreme case. By the time it's 0, 0, I mean, the alternative for that one would be to be clear on that one. Let's just write it out. The alternative would be 1423.31. Okay, 1423.318. And then that would be plus minus no, it wouldn't be even 318. It would be 31 and then 18 plus minus 23 here, right?
Yeah.
So it'd be this.
Mm-hmm.
Okay. I wonder if we have any flatter parens that don't break the well, okay, so now you're looking at this.
Yeah, Jeremy has some ideas in that respect here. Further them.
I see them. Explain these to me. Why do these make sense?
Well, I mean, I haven't seen these in books, but it goes in the same direction of being flatter.
Yeah, I agree.
That's where I started, and I thought ceiling floor wasn't the worst analogy there, right? The plus minus. I don't know. I felt like there was some connection there, although I don't.
Let's try and understand the connection. Well, let's try and understand it. So, let me see.
Just kind of saw the top end, bottom end of that range.
Yeah, right. Does it make sense to be that way around, top to bottom, as opposed to bottom to top?
I put top first because the plus. I just read it plus minus. So
I see.
It kind of works better visually. Somehow it looked better this way too.
Do you think that there are flatter? I mean, if we're drawing a character, we could draw a flat paren.
Yeah. Although you have to, can't be so straight that it starts to look like a digit.
Exactly.
You have to be careful.
Yeah, right. But it probably could be compressed a bit.
Yeah.
I mean, even if we went here, I'm kind of curious what it looks like if we go, if that's small, is that crazy? In other words, if it matches the size of the plus minus thing. See what I'm saying? So
not crazy, although not sure it'll work.
okay, so let's go.
Yeah. Although it's good to judge these at real size because the impression is way different when you scale them up.
Yeah, we could also center that. I mean, that should be centered. That should be pushed up.
Yeah, that would help. Definitely. That
arguably
pushed up, it might be nice, actually. I think that would actually look really good.
And why are we not pushing this up? I mean, I don't know how. Do you know how to do that? There's a way of doing a nudge. Why can't I select that? Okay, so this particular thing Is it control, up arrow? Oh my God, no, definitely not. That did something totally weird. That was interesting. I had no idea. It's some Mac thing. Okay, format. Where is it?
Insert typesetting.
Well, it thinks nudge up. Oh, splat. Well, whatever. Whatever. Okay. I think this is going to work. Okay. And my suggestion is that we switch between these forms.
Yeah, the idea of 1,000, I think looks reasonable.
What do you mean? Sorry?
Yes, so the 0023, I think it looks good, still look good. But more zeros, perhaps we could switch.
Right. I think there's some standard, and Michael would know what it is for doing that. But, there'll be a breakpoint, and it's probably, maybe it's two more of those. I'm not sure. And obviously, also, the other degree of freedom is going to scientific notation for the whole thing.
Right.
All right. I think we have a winner here. I really quite like this. I mean, this particular notation, after the embarrassment of realizing I didn't know how to read those numbers after all these years, because I've never actually used the last digits of Avogadro's number, this is very clear, I think.
Mm-hmm. Yeah, I agree. I think this looks very nice.
Okay, now I'm wondering about this one. Yeah, it's fine. It's fine, actually. I mean, it's using the same plus minus convention, but it just isn't parenthesized. So it's all good.
Mm-hmm.
Okay, we got a winner there. All right, should we go on to our next topic?
Yes, I think Jeremy can leave now.
Okay.
Okay, sounds good.
Thanks.
Yeah,
Thanks.
thank you, Jeremy.
Bye-bye.
Okay, so subset map. Yes, so two things. One, I tried to write a ref page, but this is quite difficult to explain. So, yeah, do you remember the problems we had with fold pair list? I think
yes, I do.
So this is kind of similar because we need to request that the function returns a list. So the first two lines are alternatives for explaining the main thing.
Replaces the I. Wait a minute, it's not F of that whole thing.
You see, it's...
Oh, it's the F of the I's.
Exactly.
Yeah, the E of the I's.
Exactly.
I think the first form is better, but I think it can be made clearer.
Mm-hmm.
By the way, Kth should be K superscript th.
Yeah.
There's a special input thing for doing that in DocuTools.
I see.
Wait a minute. What? Now I'm totally confused. Okay. The I-kth element.
Yeah, imagine that the second list, so the third argument, started with a 2. So we would be replacing the second element of the full list by the second element of, by the first element returned by F of the sublist.
Okay, let me try one time here, okay?
Yep. Mm-hmm.
Okay, so we want to say Thinking. Okay, I want to try doing this with ij ... Maybe a mistake, but let's just try it. Okay. Okay. Evaluates f of e, I, e, j ... No. Okay, hold on. Evaluates How about that?
Yeah.
I mean, it gives a list. Wait a minute. Gives a list of the
I would avoid using mapping because there is not a mapping really here.
Despite the name.
Yes, yes.
Okay, but I don't want to say replaces because okay, replaces parts. I want to say with replaces the elements. No, replaces. Gives a list No, I don't want to say list twice, you see.
Yep.
But I don't, replace is just suggested, does it in place?
What do you mean? It does use replace part internally.
I know. Gives, well, let's see what replace part says here. Yeah, yields an expression. I think that's decent. What do you think?
Yes. So the only thing I would perhaps miss here is the fact that EI is replaced with the first of F of blah, blah, blah. So this
is saying that EI are replaced with the elements of the list obtained by evaluating that. It's ordered, right?
Yes. So that's the thing which is understood, right?
That's what I'm saying. Yeah.
Okay. Then yeah, this looks good. So the function, well, there is an implementation in the X kernel. It works also with the case in which instead of I and J, we have lists. So they represent positions in something deeper. I think I think I can follow this model.
I'm going to delete these for now.
Yeah. Yeah, and you can remove the comment before.
Okay, and then this obviously gets changed to IJ.
Yeah. Yes.
Let me try it in the X kernel. Do you have any examples here?
Two simple ones.
Well, those are perfectly sensible.
Yeah, so it has to be examples that cannot be easily reconstructed with mapping.
Right.
It's not there yet?
Hold on. Maybe I don't have this yet.
Perhaps it's not today. Oh, it's a few days ago. Yeah, no, it's not there yet.
Okay. But I think a good example, so the other case we need to do is the case where there's a list of lists here, right? I don't think the list of lists should go deeper. I think that should be multiple places to apply the F.
I don't understand. I was thinking of a case in which we want to act on a matrix, for example, because we want to do this with columns rather than rows.
Okay. That makes sense. But so, for example, a sorting network would be a fold of a subset map.
Exactly.
Fold list of a subset map. And that would be a good example to show, I think.
Yes, certainly this will go, at least in applications. It may be a bit complicated for basic example.
Yeah, it's not a basic example. Yeah. These are good basic examples. I mean, I think you could have I think in addition to accumulate, you could have one that is just total. Although, can you do that with a replace part?
But total, so we need a function that returns a list from a list.
Right. A list of the same length.
Exactly. without having to write appends and things like that. So these two are nice in that respect.
N Genesis on the live stream is suggesting replaces E sub I sub k with the corresponding elements of this. I agree that corresponding elements would be useful here.
Mm-hmm. Yes, I think this solves the slide worry.
In which they is that useful to say subset of parts, or is it not really useful?
Well, it's not that useful, but it links nicely to the name. So it may be good to have it.
Fine. Okay. So just to be clear, this function, for example, for our quantum, I mean, I think the cases that are worth showing here, I mean, one of our quantum, some basic quantum gate is probably worth showing. So some reversible logic gate. I mean, for example, I'm pretty sure in the NKS book, there's a grotesque implementation of reversible logic. Let's take a look. Okay. Oh, that's interesting. So the point here is, right, so you can give a permutation. So for example, in the subset map thing, what you would give, let's just write out what that looks like. So for example, that would be a permutation that you give. So you can give A, B, C, D, E, F, G, and then you give 2, 4, 1, for example. Well, that's confusing, but I mean 6, 4, 1, right?
Yep, I see.
Now, you could also do that permutation. The only other way to do that permutation there is a permutation function which would do that, I think. Is that true? Without having to give the other elements as, this is not completely trivial, right? Is there a way to apply the permutation 231 to those elements? I don't think there is.
No, I don't think so.
Right. So that's an example, and I think it's worth looking at some. Here, let me just send you this one. And I'll also send you the page of the NKS book, which talks about reversible logic, because that's basically talking about the fundamental point there. Oh, let me see. You're taking a Boolean function of 3 variables. Yeah. Okay. So hold on a second. So the typical case there is you're taking. Yeah. So just to give okay, what you want is the tuples. Okay. Here we go. Tuples 1, 0, 3. Okay. Right. So there's a function. Each one of the 8 factorial possible ways of rearranging those tuples corresponds to a ternary gate.
I'm sorry, I'm thinking that the function permute with cycles would be able to do that. Because the cyclic notation is able to select a few elements without specifying all the rest.
Okay. Okay, fair enough.
Mm-hmm. Yeah, but still, this is a good example of the general power of this function.
Right. Now, it's a little unfortunate that, a typical thing might be something like this. That would be a reverse. By the way, I would recommend, we're using reverse. I would just use reverse for the, whatever. The rotate left probably requires a little bit more thought than reverse.
Right, yeah.
And you could just do reverse with 2 elements to begin with, to make it clear what that does, that it just flips them around.
Yeah. Mm-hmm.
It's not obvious how you would do that in, you can do it with a permutation thing, and that should be in properties and relations.
Mm-hmm. Yeah.
Okay, great. All right.
So, before we go, there is an issue here, which is this next comment, which is whether we allow expressions in the second argument with other heads.
No. Why would we want to?
Well, it may be useful somewhere, but it's problematic because first there is the question of what do we feed to F? If we extract things, do we feed and list or the head that it had originally?
Right. Is there head matching or not?
Right. And the second difficult question is what do we do with holding attributes? There's the question.
Let's not cross this bridge. Let's get this thing in there just for list.
Mm-hmm. Mm-hmm. Okay.
Okay.
Mm-hmm. Yeah. So that works already in the next kernel, in our more recent.
Okay. Mm-hmm. Good stuff. All right. Should we go on to the next?
Yes. So the next one is a double suggestion. One is the idea of adding an option same test to the functions subset q, intersecting q, and disjoint q, so that they can compare their elements to decide membership. So I've added there the list of other functions that already take the same test option. And I think this is perfectly consistent with the fact that, for example, the contains family already takes that same test option.
So intersecting Q, okay, it just allows 2 lists.
Mm-hmm.
It's not a Verogs.
No. But even, for example, intersection is Vararg, and it does allow the option. So I think for consistency...
Yeah. This is reasonable.
Yeah, I think so.
Okay.
Yes, but there is something else. So delete duplicates is another function that for which it is important to have same test, but it has it as an argument rather than an option.
I think we should allow the option as well. We've done that in a bunch of other cases.
Right. The main thing for me is that there is also delete duplicates by, and because it needs the f function argument, it cannot have this other one. And so the option would be very useful there.
Fine. Then support the option also as a courtesy and delete duplicates. We might even not want to document it, but then delete duplicates by, you obviously have to document it.
Exactly.
I'm okay with this.
Okay. And then there is a second part of this, which is tolerance. So Charles is asking for having tolerance argument in delete duplicates. So this is the list of functions that take the tolerance option, which are all, of course, very numerics oriented. And there is a group of them which take both same test and tolerance, which are the matrix predicates. Okay. So in a sense, delete duplicates would belong to this case of taking both.
So what it means, if it's within the tolerance, it's considered to be a duplicate, zap it.
Right.
Okay.
Yes, there is a slight issue here, which I'm discussing with Rob, which is if there is a matching, so there are two numbers with respect to the tolerance, which one do we return, or whether we return some sort of canonical representative of the equivalence class, things like that.
I understand. Yeah, right. So if there are two numbers, if they're not exactly the same number and you're deleting duplicates, and what will be the default tolerance? Like for machine precision, there will be a tolerance if you've got machine precision numbers. I mean, right now, let's just do this. I mean, if we say 1 point, 2 point, 1 point, 1 point, okay, all good. And now we say delete duplicates of that. Okay, great. Now we say 1 point plus 2 times dollar machine epsilon. Interesting. So the claim is that this would now be, if I did 1 times machine epsilon here, or maybe I do half a machine epsilon there.
Right.
Oh, that already works.
Okay. Yeah. So this is using same Q. And same Q, I think it has 1 bit of tolerance.
Okay. But what canonical representative does it return?
That I don't know.
I mean, the obvious possibilities are first in the list. I think that's the right thing to do. I think almost anything else is going to be a little bit crazy. I mean, the other thing to do would be, but it's crazy, is number with fewer it's crazy. I was going to say more round number, but I think that's crazy.
Yeah, that's probably unstable, yeah. Yeah, the first one is probably a good idea.
Okay. So that would be my suggestion. Okay. Go on.
Yes, and the final thing is a more open discussion. It's whether we can have a symbol any representing any choice in a given argument. So, for example, this has appeared in the discussion of how to represent arrays of any dimension. So, for example, in the last line, arrays, the first argument represents the dimensions of the array you are dealing with. So how do we represent all the arrays of any dimensions, but still being symmetric?
What's wrong with blank?
We could use blank, yes, but somehow blank seems like committing to using the pattern matcher. So it's giving more power than perhaps is needed there.
Well, the question is, I mean, I agree that along with all and none and so on, any might be an interesting thing to have. Let's try to inventory whether there are places, I mean, there are places where we've probably used all where any might actually be more appropriate.
Exactly. Yeah. Because somehow all means you are considering all the possibilities at the same time rather than one of them.
Right. I think I generally support the idea of introducing this. It would just be nice to know where else we care about it.
Right, exactly. Okay, so I'll try to inventory places where we could use it.
Fine.
Mm-hmm.
Okay. All right.
Okay, well, so we went fast today through the agenda.
Right. Let me ask about a couple of things here.
Sure.
So, around the around stuff is all coming together, yes?
Yes, we are moving forward with it, yeah.
Is Brett succeeding in supporting it in the visualization functions?
Yes, they are working on that, and there are a few options supporting it. I think they are called error. I mean, they support various forms like pairs and errors and
right, but I mean, is it something that list plot on its own is going to support, or is it a new list plot?
No. They are options of the previous functions that specify how do you want to support it, whether with a bar or arrows.
Okay, fine. But there's a default, presumably, in list plot that does something reasonable.
Yes.
Wonderful.
Mm-hmm.
Okay.
Mm-hmm.
Okay. Question for Sushma. Is Sushma here?
Yes.
All the various things that are green lighted and are steaming forward, are they all steaming or have some of them run aground?
No, most of them are done, and I think we are waiting for documentation and things.
Okay.
The
so
one
the
which
things
we
that
decided
I've marked as green lighted from a while ago, so base encode, base decode, those are done, right?
Oh, I did not know you were talking about this notebook, but let me check.
That was done, but under a different name.
Those were done, but like in a very, I think it was in a different name or something. I need to look back at my notes.
Yeah, so I see construct there, which is done already.
Base encode. Yes, that's done.
That's done, but
so actually we should mark these in this notebook and move them over. Screen capture is done. Construct is done. What is contains?
This one I don't even remember.
I think
that's not done.
Yeah, that's not done. And we also that came in a discussion with construct, and we did not really green light that, I think, because
Which
I remember
one?
Contains.
I can imagine that contains is somehow related to the contains family. I mean, it should be, but
yeah, I don't know what it is. Sushma, maybe you could go find out what we were thinking of there.
And I will add those information in that notebook.
Okay, signed number form. Or was that something which is going to be an option to number form? Can you go check into that? I mean, it's whether to display the plus sign. Okay, capitalize. Did we think we've done this or not?
We did that.
Yeah, we have the various forms there. The only pending thing, which was a lower priority, is to look at having alternative versions of title casing. So we have our primary version of title case, but there's AP standard Chicago manual of style.
You know, I'm going to add that to my list of potential student projects.
Yeah. It's something that was on the agenda, but we marked it as relatively low for the moment, but it would be a good student project or intern project.
Okay. So e.g. AP style and so on.
Yeah.
Okay. All right. I don't think that needs to be on this list here for right now. I mean, it's Okay, normalized vector and vector magnitude. That was done, wasn't it?
No, it is not done, but it is in that non-project, which is like actively being worked on right now in LCC.
Okay.
And
this one is done,
that
right?
is done, yes.
The byte array is done.
Yes.
Restart.
That is not a function that I've been tracking, but I can check with Roman.
Please do.
Yes.
Channel receiver function. Did that get done?
I think channel receiver function is a function.
Yes, it is. Great. Take list was done, right?
It's done.
Yep.
January, February.
I need to check on that.
I don't think that was done. Decimal form is done.
It's done.
System process data is done. This whole business of changing with, that is not done.
That is not done.
And that needs to be pushed some more.
Okay.
Scan index. Did we ever do that in the end?
No.
No. I think we should abandon this. It's
okay.
I'm not sure.
Nobody cares.
Exactly. Yeah.
Okay, so Sushma, can you move these things into the appropriate done and abandoned notebooks and so on?
Yeah.
So inferred replace is a cesspool of.
Yeah, we did try, but it was too big. This is the sort of project which is the size of the predictive interface or something like that.
Well, it's also not clear it's worthwhile.
It would be interesting if it worked, but it's a lot of training.
It's not clear it will work. It's not clear it will ever work. I'm adding that to my student list for further exploration.
Okay.
But I would abandon it from here. Okay. All right, that's those ones. Let's just have a quick look through Humph. Where is it? Sorry. So okay, so semantic cases. Oh, by the way, are you tracking n-body simulation?
No, I'm not tracking that, but I've been in a meeting once because somebody needed to take notes.
Okay,
but
can we figure out who is tracking it? It needs project management.
It's Rob's project, and I can ask him.
Okay,
Yeah,
but it needs project management.
I have been in contact with him in relation to quantity manipulation support there.
Okay, great, because that's important.
Yeah.
Okay. Okay, so we've got quite a lot of things here, which are like this whole semantic cases thing. That's a machine learning thing.
Yeah, we've discussed that in machine learning meetings, and I remember Julia was supposed to look at image cases part of it, and that is where we decided to start it from.
Yeah, I know, but then Jerome was supposed to look at the text part of that, correct?
Yeah, and he's working on those.
Okay, so that one is Jerome is working on. Okay, I have no idea what multi-resultant even is. Okay, this whole thing about delete outliers, is that part of what will come out of the machine learning stuff?
It's part of missing imputation thing that Amir is working on.
Okay, but then can we please make sure that these functions, okay, so that is being worked on by Amir.
Yeah.
Right?
Yeah. I mean, I remember talking to both you and Etienne about, and Etienne thinks that we can include this in the missing imputation project, but you were not very sure about if.
Well, fine, but I just want that particular wrapper, the delete outliers concept, which is not quite the same as missing imputation. I mean, it's a different function. It might come out of the same algorithms, but it's a different function.
Okay, so you want me to just mention that we need this wrapper with Etienne?
Yes, well,
okay.
make sure it's in the machine learning agenda.
Okay.
Okay. Host registration data, I believe, is coming along. Have you been involved in that? That's probably in the CSE meeting.
Yeah, that is a CSE meeting. I can check
Who's PMing that?
Carla.
Okay. Can you check that, please, and get something added about who's doing that?
Yes.
This can of worms. Any idea what's happening? That's Yutsu in John's group.
I will find updates for that.
Okay. Okay, clean data set. Well, that has to do with, that's part of the data set development project, for which I think what's happening with that is do we agree Igor is going to do that, or what's the story there?
No, basically data set is with me right now, but I don't have much time to put on it. And what will be really important is to get Chris, for example, to work on.
Oh, yeah, that's right. Right, that was the idea.
Typesetting.
What we got to get Igor to work on?
Sorry?
What were we getting Igor to work on?
We discussed about it, but his manager thought he had other things to finish first.
I'm rolling my eyes, but okay, fair enough. Okay, but the story of getting Chris to work on data set, when is that going to happen? Did he start looking at it at all?
Not, because he's still working on the Wolfram Alpha notebooks and updating the predictive interface for that. But I think if we get the approval from John Fultz, it should be.
Okay.
He was interested in dataset, certainly.
Okay, let me just okay, array association.
So that's on my plate as well, also related to dataset, because it could save much space there. But no, I'm not working on that right now.
Okay. We might want to look at somebody else taking a look at that. Is that something Konstantin could look at? Perhaps I can ask. Certainly this would be like a multidimensional form of association, which is a concept that might be useful in other places. Well, but this is a thing that wasn't actually stored as a multidimensional association, was it? It's something that creates a structure that is like multidimensional association.
Yes, we have discussed both concepts. I guess I was talking about association array rather than array association. We have talked about both things. So this was the constructor. How did I call it? Thread, key thread, or something like that?
Yes, you had other names for it.
Yes. But both ideas are useful ideas.
Okay. Maybe we need a separate... let's put that on the agenda for another ILD meeting.
Yeah.
Okay. This fine character encoding, Ihe, is supposed to have done this, right?
Yeah. I mean, it's something that she's working towards.
But I thought that was okay.
It is almost about to be done. She's reviewing the codes with people.
Okay. Session data or session information. Did we explore that or not?
We did explore that.
Was that in the CSE meeting or what?
No, it was discussed in, I think, one of ILD or LCC meeting. I'm not quite sure, but we did discuss that, and we decided to make a very basic implementation of session information, and Lou was supposed to work on it, but then Lou got very different projects to work on. So that is a bit stalled for now, but I can push that.
Okay. I don't think it's that important.
Yeah.
Column map and those ones, I think that is worth doing. Where was that at?
In our last discussion, I was trying to convince you to have a second argument in map rather than all these new functions. But I mean, I'm a bit worried of introducing so many functions.
No, I agree. Well, let's bring that back again. We didn't come to a conclusion last time, right?
No. The last time you still wanted to have all these separate functions, but it's going to be many.
Okay, fine. Well, let's bring that back again to another ILD meeting.
Yeah.
Okay, what happened to flattened?
Yes, so we discussed about its extent, and we decided to have something smaller, and this is easily implemented. I'm not sure whether we gave it to Konstantin or...
Okay, so Sushma, you should check.
Yes, I mean, if he cannot do it, I can do this as well.
Okay,
this is simple enough.
Yep.
Whatever happened to file partition? Didn't we do that?
I don't think so. I don't think so.
Is that a CSE project?
I was told to send it to CSE at some point, and I did send it. I don't know if that was discussed in CSE at any point, but I
think it was discussed, and I think why don't you determine what happened? We might have killed it. I'm not sure.
Yeah, okay.
That's one for Roman. Could you determine there?
Yeah. I will send that to him.
Okay, this is all related to the geometry project, which, by the way, I wouldn't mind seeing another update on. But is this actually in the geometry project or not? Let's determine that.
Do you mean Roger's project or?
No, I mean Michael and James's project.
Yeah. I see them merging now. I mean, they are working on merging it now. So
that's great.
Mm-hmm.
That one is in progress now. We just went over that yesterday. This one is now eminently doable, and we should just do it. That should be given to Garrett, who can get Suman to do it.
Okay.
I mean, it'll have a bunch of weird options, but it's absolutely doable with the web execute functionality. Make sense?
Mm-hmm. Yep.
Okay, GeoList plot 3D. That's on you, Jose, I think.
Yes, but this is together with many other things related to elevations and 3D. So that's going to be another iteration of Geo. I'm working on other things now.
I know. This one is beautifully in progress. Actually, I'm going to remove that from this list because I think it's just not useful to have it in this list. You agree?
Yeah, okay. And it's certainly not low hanging.
The height of the fruit is a variable in here. Okay. Okay, let's just look at a couple of these and then we should wrap here. Fraction form. What did we ever do with this? And mixed number form. I don't think we dealt with either of those. I mean, mixed number form we have in Wolfram Alpha for sure.
We are certainly not working on that. We are trying to finish percent form.
Which is really important. Okay, so these are follow-ons. Who is doing percent form?
Danny.
Okay. Well, maybe he could do these after that.
Yes.
Okay. So all three of these we need to finish design and get them ready for implementation. They're all sensible.
Yes. It's more a matter of implementation details. Mm-hmm.
I know. Right. What was this one?
I think we were thinking of generalizations of power. So in the same way that we have power being the power of times, this may be power of other products, like tensor
product. Why did it just nest?
Because sometimes you can compute faster than the
power. Using a power tree or something.
Right, rather than...
Right. That's the point. Yeah, if it's associative, that's right. If you know it's associative, you can use a power tree to compute it.
Right.
Yeah, Yeah, it's kind of interesting. Well, okay. For a different time. All right. I think we've got what we need here. Lots of good stuff. I am keen to see Chris start to work on dataset, by the way.
I will ask him. But
okay.
I think we need permission, approval from John.
Yeah. Okay. Anything else, Sushma? Nope. Okay.
Yep. I will just make updates to that notebook then.
Sounds good.
Okay.
Thank you very much. Okay. See you all soon. Thanks to people on the live stream. See ya.
Bye.
Bye.